Good afternoon, students. Today we are going to demonstrate the network theorem 1, that is for superposition theorem, and then Thevenin's theorem. So coming to the superposition theorem, we are having the circuit as shown in this figure. Can you see this figure? It is having 3 resistances with 3 ammeters which are used to measure the current of these 3 branches. That means current flowing through this R1, R2 and R3. And there are two sources are connected over here. One source is this, another is this. You can see here in the experimental setup, these are two sources. This is the first one as shown over here, and the second source is this. Now you can see here the first sources is showing 7.7 volt, which we are keeping, and here the second source is 5.5 volt. Okay, now I'm coming to the connection. What is the connection? First of all, you can see over here this A point is coming here and this is coming here. So we are giving the sources here across this two terminal. This two terminal is this. Now next is ammeter and this resistance. These two are in series. So what we have given, this is coming over here, then resistance, then resistance is these two are in series, resistance and ammeter. You can interchange the position. So first we are keeping the resistance, then the ammeter. So next this one is coming to the ammeter, and the ammeter from the another terminal of the ammeter, it is going to the next branch. That means this B point, right? So here it is the B point, right? So across this B and D, this is D point, this resistance is connected. This resistance, you can see it, this one is the rheostat. Here intentionally one rheostat is kept to show you how the rheostat is being connected. So it is the variable terminal, and you can see over here, this is the fixed other terminals. Okay, now B terminal. Now from B terminal, what it is coming here, okay, now from this it is going to this resistance R2, right, R2. Then from the other terminal of R2, to measure the branch current across R2, another ammeter is connected. So this one is the second ammeter. So this one is the first ammeter which is measuring I1, this one is I2, and this is I3. So from the another terminal of the ammeter, it is going to the source. So you can see over here, it is going to the source, and the other terminal of the source, from the other terminal of the source, here it is connected here. So this point is next. Now additionally here two resistances are kept, that is 30 ohm and 30 ohm. No need to worry about it because the same current is flowing over here. Now from across this terminal, it is going to here to measure the R3 I3 branch current, and from the ammeter, this terminal, it is going back. Okay, so this 3 terminal again connected. Understood? Achha. Now we are going to demonstrate the procedure. First, what we will do, when two sources are connected, this is the case, when two sources are connected, we will measure all these 3 currents, I1, I2, I3. So here I1 is showing 0.04 ampere, I3 is showing 0.06, and I2 is showing 0.02. So therefore I am writing over here I1 is 0.04. I am not writing the unit over here, I am writing over here. This is ampere, so 0.02, and this one I3 is 0.06 when both the sources are connected. Both the sources. Let me proceed to the second run. What is that? When only V1 is connected. So that means we have to short the V2. Let me short it. Okay. Now I am making it off. Every time you have to keep in mind that you have to make it off, and then we will do this. Now how I am doing this. Let me open this, and See, this source is just isolated. Okay, removed. Now we are going to have the next set of reading. That means V1 is connected only, and we will measure all these three currents. So now I am making it on. Sorry.
It's not required. We can switch it.
Yeah, we can switch it off. Now these are the measurement. That is I1A. Next is I2A, and this one is I3A. Okay, so let me write it out. I2A 103. So this is DC current. You can see the negative sign. That means current flowing in the opposite direction. What we have assumed previously, this current is just the opposite direction. Okay, and it should be, because if only this source is connected and this source is not connected, so therefore the current should be in this direction. But previously when this source is connected, the current is in this direction. That's why this is negative. Okay, there should not be any confusion regarding that. So that is when V1 is connected only. Now only one run is left, that is V2 is connected only, which will gives us I1B, I2B and I3B. Now let me redo the process first. I am connecting the V2 again in the circuit, in the network, and then I will remove V1 from the network. Look at here, it is being shorted. V1 is shorted. That means we are removing this one. Okay, this 2 points shorted. Okay, now I am making it on. Remember that V1, V2, V3 value should not be varied during the whole experiment. Okay, now let me measure. This one is I1B. You see, it is flowing in the opposite direction with respect to the previous one. This is I3B, and that is I2B. All are in ampere. Now we are going to verify the superposition theorem. How? I1 should be equal to or close to I1A plus I1B. Acha, I1A is 0.06 and I1B is minus 0.02. What it is coming? 0.04 ampere. And look at here, I1 is perfectly 0.04. So we can write it here, verified. Right. Next is I2A and I2B. I2A is and I2B is 4 ampere, and I3A and I3B. I3A is 3 ampere. Now look at here. I2 is 0.02 and this is 0.01. That means it is close to this. So here also we can write it verified with little error. Similarly, it is 0.05 ampere and here it is found out to be 0.06. So here also these are close to each other. So therefore here also we can write it as verified. So with all this with this experiment we can say that superposition theorem is verified here perfectly, and in this too with little error. So in a nutshell we can say that this is the superposition theorem is verified satisfactorily.